You know that you can design structural elements if you can model it properly. Today, I will show you how to model, analysis and design spiral staircase in CSI ETABS software. After modeling this project, let's proceed to analyze it to get design moment. Using this Excel template shown on the screen, we will calculate area of reinforcement, that is AS, and we are going to decide diameter and spacing of reinforcement. If you have interest on this design template, announce me on the comment section. Watch this video up to the end to master structural designs of spiral staircase. Now it's a time for subscribe my channel to get daily update tutorials free. Thank you. Let's dive into today's tutorial. The spiral staircase that we are going to model today looks like this. At the top there is a landing slab, and when change it to plan, there is 4 columns around this spiral staircase with a spacing of 5 meters in both x and y direction. So let's go to model this spiral staircase together. So go to file menu, new model. Let's use a model file that we are going to set before. So make it okay. Let's use this model. After that, the new model initialization box is coming like this. So the grid line in x direction, let's use 4 number both in x and y direction, and the spacing of a grid line in both x and y direction, let's use 5 meters. So let's use the default grid level as it is, and the bottom story height, let's use 3 meters. Typical story height, let's use 3 as it is, and the number of story, that is total number of story, let's use 4 stories. After that, make it grid only. Okay. So our grid is coming like this. So let's draw our columns. To draw our column, let's make it all story here. After that, make it plan. So starting from the 4th story, let's go to draw all the columns. So to do this, let's go to quick draw columns. From here, let's change the property. So for this tutorial purpose, let's take column that is a section property of 30 by 50 centimeters. So let's draw our columns like this. After that, let's go to draw all the beams. So let's use a property of 40 by 20. After that, simply let's click like this. So all the column and the beam is drawn like this. After that, go to the plan view. So let's replicate this beam to get the center of the spiral. So to do this, go to replicate menu here. After that, the center to center spacing is 5 meters. So let's use minus 2.5 meter here. After that, let's select this beam and go to the edit menu. From this edit frame, so divide frame, divide it into 2. So our beam is divided into 2 parts. So let's cancel this part. So let's go to draw our spiral staircase using this frame, starting from this center point. So to do this, first you have to select the property of the stair. So to do this, I have to select stair 180. After that, let's go to select this frame. After that, go to the edit menu, extrude frame to shell. So from this you have 2 choices, that is a linear and radial. Make it radial. After that, to get this coordinate, you have to select one, or you have to pick one point on your model. So make it this. Yes. After that, I have to go to fill all this data, that is the angle, the number, and total drop. So the number, let's make it 28 risers. After that, to calculate the angle, I have to use 360. This is because our staircase is radial, divided by 28, that is the total number of risers. After that, I have to get all the angles of each riser like this. After that, the total drop, let's take the story height as a total drop. After that, make it apply. Okay. Let's make it in 3D. So our spiral stair is drawn like this. After that, go to the plan view. Make it story 4. After that, I have to go to draw the landing beam. That is, make it slab 180. After that, you can draw like this. So have to delete all this beam. It's not actually necessary. Make it delete, and also make it in 3D. Sorry, make it one story. After that, I have to delete all these landing beams that are not necessary except at the top. So make it delete. So our staircase looks like this. You can draw a beam around the interior or the exterior edges of this staircase. So to do this, make it in plan. It's better to first select the material, beam 40 by 20. After that, let's go to make it all story. So let's go to select this joint, make it 3D. To draw the beam to the exterior sides or edges of this spiral stair. So actually this is not necessary. You have to cancel at the base. After that, go to edit menu, go to extrude joint to frame. So in similar way, you have to use the radial position. After that, make it plan. So I have to draw starting or I have to pick one point here, that is the center point, and put all this data in similar wise to the slab. So divided by 28, have to get the angle. After that, make it 3, apply OK. So make it in 3D. We are going to draw beam to the exterior edges like this. If it's necessary, you can draw also in the internal face, but in our case it's not necessary actually. But if you want, you can draw in this way. So let's apply a load that may be the dead load or the partition wall load and that of the live load. So let's go to select menu. From this select by property, make it a slab, that is slab 180 and stair 180. Select it. After that, let's go to assign a load, that is go to shell uniform. So let's go to a partition wall load. So for partition wall load, let's assign minimum partition wall load, that is 1 kilonewton partition wall load. Previous selection, let's go to assign menu again, shell uniform. From this, let's go to assign a live load, that is for staircase. It's better to assign more than 3 kilonewton live load, 3 kilonewton per meter square live load. So make it OK. So all the load is assigned on our staircase. So let's check the load combination. From this, let's go to define menu. So the load combination here. So the factor then service load combination is defined like this. So you can check all my tutorials here. So let's go to analyze this model. But before the analysis, a spiral staircase may be act as a wall or it may be act as a slab in both manners. So let's go to mesh this as a wall and floor. So to do this, let's go to the analyze menu. From this automatic mesh setting for floor. So I have to use a 1 meter stripes. So it's better to make it OK. After that, let's go to the automatic rectangular mesh setting for wall also. So make it 1 meter. After that, make it OK. So let's proceed to the analyze menu to get the maximum design moment for this case. So let's analyze it. The analysis is completed like this. After that, let's go to the display menu. From the display menu, force or stress diagram, shear stress or force. So from this, let's select the factor load combination, that is load combination 1. Let's click on the M max, that is the maximum moment here. Make it OK. So the maximum moment is M max, that is 166.525. So using this moment, let's go to calculate all the area of reinforcement and the spacing of reinforcement in detail using this Excel spreadsheet. So our movement, so all the data are filled like this. So the moment that is 167 kilonewton meter. Yes, using this design moment, area of reinforcement calculates by this Excel spreadsheet automatically. That is 2620.711 something. After that, let's go to use diameter of reinforcement to calculate the maximum spacing. So for all these cases, you can use all these formulas in detail. So I will share this file. For a diameter of 12, let's use 43, that is 40 millimeter spacing. Actually, it's under that because the minimum spacing is 75 millimeter that the record will declare. So it's below. So let's go to a diameter of 14. So if we are going to use diameter of 14, the spacing is 58.79. That's actually 50 millimeter. It's under that specification also. So let's use a diameter of 16. So using diameter of 16, I have get 76 point something. That is 75 or 70 millimeter spacing. So let's change this as a diameter of Tioni. After that, the reinforcement detail is calculated as it is. So you can use 110 millimeter spacing to as a diameter of Tioni. These were the most important part regarding to model analysis and designs of spiral staircase. Thank you for watching. See you in the next important tutorial. Goodbye.